To look at graphs of functions and how we can solve them without knowing what the function itself is. So here I've got fx, or y equals fx. It's been drawn for me, and the first thing it asks me for is to solve f2. Now that means I'm going to put 2 instead of x. So I've got the x value, but I'm trying to find the y value. So I go along to where x is 2, and I simply read down to here, and I look across, and it gives me -3. It's as easy as that. B, this one's different. This wants to know what the x, we've got to find the x value given that it equals 1. So what I've done is I've replaced y with 1. So I'm going to draw the line y equals 1 along there like that. Let's just reposition that line. So here is y equals 1. The 1 there means I'm going to make it y equals 1. And I look to see where they coincide. So there's one value there, one value there, one value there. And I want the x numbers here because x is the thing that I'm looking for. So that's x equals -0.9. And because I'm using the graph, I only have to be approximate 0.8 and maybe 3.1. Now this part C is going to require some thought. Given that fx equals k has only one solution, find the value of k. So k is like the number 1 here. So imagine k was 1 and I drew that on. I've actually got 3 solutions. So I need to think about where I'm going to draw this line. So imagine I draw a line there. There's still 3 solutions. So I'm going to move it up. There's still 3 solutions, 3 solutions, 3 solutions. Right there, there's probably 2. If I move it up again, there's 1 solution because it only cuts through 1 time. So I want k to be maybe a tiny bit bigger than 3. So k has to be larger than the highest point of this graph, which is 3.1, roughly. But we can also move the k down to the minimum point of the graph there. So there's 3 solutions there. There's 2. So it's below the minimum point here, and the minimum point looks at -3.1. So I'm going to say and k is below 3.1, -3.1. So those are the 2 places for this k value. Quite a tough question. Okay, finally, I'm going to look at 2 functions drawn along the same graph. So I've got fx and gx, and I want to solve fx equals gx. Relatively straightforward, it's just where they intersect. So I'm just going to look along here and say, here is one solution, here is the other solution, here is the third solution, and it's x that I don't know, so I want the x value. And again, I'm using the graph, so it's -1.3, 1.3 at this second value, and maybe 2.8. But they're approximate because I'm using the graph.